Hello there. I'm William from Spatial Pixel, and this is the first tutorial in our Spatial AI Technical Workshop series. This one is about how to use a feature of large language models called function calling, specifically that from OpenAI, which enables LLMs like GPT to ask for information from and even act in the real world. For example, this is Spatiality. This is a playground I've built for experimenting with LLMs as spatial reasoning engines. In place of the real world, though, on the right, Spatiality interacts with simulations of the real world, like the rigid body physics engine here. So, as you can, in this example, you can see some simple text prompts to add cubes to the scene on the right, and then we'll be able to interact with the scene and query it from the large language model. So, function calling is what enables us to do this. So to do this, we're going to have to learn some basics of the OpenAI API. Let's get started. This tutorial is written for beginners, so it includes some recommendations about tools and explanations of how things work that experienced coders might already know. So if you are an experienced coder, you might want to skip forward to the section on chat completion API calls. All the code will be available on GitHub. So chat interfaces like ChatGPT, most of them act kind of like this, where there's a context that sets up the conversation. So ChatGPT calls this custom instructions. And then there's a user prompt that's provided. That goes to the LLM, which then returns a completion. And then we're able to chat with the LLM by going back and forth between user prompt and completion, stacking all of those together and handing all of them to the LLM at once. The problem happens when the user asks for something that the LLM doesn't inherently know, something like the current weather. But what happens is LLMs actually allow us to locate and find those places where users are asking for information outside of the LLM's bounds. So that's called a function call. So instead of returning the completion to the prompt, the LLM returns a prompt to us to call a function that we've already told it ahead of time that we've defined. So then what happens is it's our responsibility then, in this case, to go get weather data from, say, an API or weather API service, and then return that to the LLM as a result of the function call. Then what we do is we bundle everything together and send that to the LLM, which then finally returns the completion. This is the flow that we're going to do in this tutorial from end to end, starting with the first bit, the basic chat. So to do this, we're first going to need to get our tools together and get our workspace all set up. So to start with that, we first need an API key from OpenAI. So you can do that by going to the OpenAI website, platform.openai.com. Once you sign up for an account and then set up a billing account, you're able to create an API key here. So I've already created an API key, and so I'll be using that later on in the tutorial. To set up the environment for us, we're going to be using node.js. OpenAI does provide a Python SDK as well. Node.js is better for us because of the spatiality environment. It actually enables us to put much more interactivity into the browser when combined with libraries like p5.js. So, but the Python SDK is certainly as capable, and this whole tutorial could be run with the Python SDK as well. If you're new to coding, I have a few recommendations for which code IDEs or code editors are the most popular. So Visual Studio Code is probably the most popular professional code editing software out there. I use a variant of that called VS Codium. My daily driver is actually Nova, which is a Mac native code editor. And Sublime Text is equally as popular. So we're going to need a code editor like this. We're going to need access to a terminal emulator. If you're on a Mac, the terminal app is already installed on your machine, so that's perfectly fine. My daily driver is iTerm. If you're on Windows, I highly recommend PowerShell. This provides a lot of similar interactions to the Mac terminal. Okay, so let's get started. So after you get your API key, the first thing that we're going to need to do is just create a folder to put all of our work. And so here's the home folder on my machine. So I'm just going to create a new folder called functions. All right, so now I just have to load this or open that folder in my code editor. The goal is to have our code editor, our terminal, and our Finder window or Explorer on Windows pointed at the same folder. So I'm just going to go to VS Codium and open that folder that I just created. Okay, now we're going to go to the terminal. If you're new to this, the terminal can be a little bit tricky, so let's go over some of the basics of how terminal emulators work. So a terminal emulator is just an app that provides an experience that's similar to the physical terminals that were the original ways to interact with mainframes when they were still around. And so a terminal emulator runs a shell called, in this case, it's either Bash or Z shell, and that provides a kind of command line interface experience. So it's similar to kind of a chat interaction, but instead of natural language, we're going to use formal commands that are available through the shell. And so when you first open your terminal app, you're going to want to type pwd for personal working directory. So one of the pieces of state of the terminal, which is pretty similar to Windows Explorer or Mac OS Finder, is that there's always a folder that it has open and targeted. So that's the context for all of the commands that we're going to run. Here, when you type pwd, it shows you what that folder is. In this case, my home folder. If you type ls and then enter, you'll see a list of all the files and folders that are in that working folder. And so you should notice that all of those are identical to the folders that I have in my home folder that I'm looking at in Finder. And so Finder and the terminal app are looking at the same files and folders. So commands like pwd and ls, some of them also have the ability to give them arguments. So if we say cd for change directory and a space, we can type the name of the function that we just wrote, which you can see up here in the list. And once you press enter, that changes the folder that we're looking at. So if you type pwd again, it'll now show you the path to the folder that we created. And so in this context, when I say folder and directory, those words mean the same thing. So now we have a terminal on our Finder and our code editor all looking at the same folder. The next thing we have to do is just check to make sure that our node.js installation is working. So if you've installed node.js, which, by the way, the LTS version here on the left is probably the one to install. You should be able to type node and a space and then -- version to see if it works. You should get a number like this. I don't have the latest version, but any one of these V20 versions should work just fine. Great. Now what we have to do is actually install the Node libraries that are provided to us from OpenAI. And so to do that, there's another command that the Node installation has installed called the Node Package Manager, or npm. So type that in space, install, and another space, and OpenAI. All right, so this actually installs the OpenAI libraries. If you type ls, then you should see a few files and one folder that the npm tool has created for us. So now in this context, we're able to use the libraries provided from OpenAI. Now we have to put the OpenAI API key that we have into the environment that we're going to run our commands from. And so if you look back at the documentation for the OpenAI platform, under Quick Start, there's some instructions on how to get the OpenAI key into your environment. And so if you look at setting up your API key, it'll give you two sets of instructions, one for macOS and one for Windows. For Windows, it uses the PowerShell command setx. For macOS that I'm on, you don't actually have to follow through with all of these commands to edit your bash profile. You can actually just copy this right here, and then insert your API key where it says your API key here. You can copy and paste this into the terminal, and that will make this work for just that terminal session. So it's up to you. I already have the OpenAI API key in this environment, so this is ready to go. What we're going to do is run a simple test to see if the OpenAI API is working. We're going to go to our code editor, and then you should see the same files from the terminal here that the npm tool created. We're going to create a new file and just call it models.js. Now that we have our file, the first thing we need to do is actually import the library that we just downloaded so that we can use it in our code. And the way that we do that is like this. We define a variable called OpenAI, and then we set it equal to this expression, require OpenAI. So it's a bit confusing if you haven't seen this before, but the OpenAI in quotes here, this is a string that refers to the module that we imported in the terminal. This is a variable that we're creating in code that refers to the contents of this module. And you can see it has a different capitalization. That's really for us a convention so that we know that this is an object of a particular type. Now we actually have to instantiate an instance of our API. And so it looks quite similar to what we just wrote, but we use the new keyword and instantiate this model like this. And so this actually does the work of accessing the API key that we put into the environment when we actually execute the code. Now what we're going to do is, just by convention, create a main function that will encapsulate all of our logic. So the way we do that is this. This defines a top-level function called main. And don't worry about any of the other annotations just yet. Just note how we're using opening and closing parentheses and opening and closing curly braces. And if you're new to an IDE or a code editor like this, you'll see that it's automatically putting in the matching opening and closing braces for us. And here we're going to run this simple test with the API to get a list of the models that OpenAI offers. So it's just a kind of simple request to see what's available, and then we'll go to the website and show you the actual content. The way we're going to do this request is we're going to create a new variable called list. We're going to set that equal to this API call, await OpenAI.models.list. What we're seeing here is a little bit of insight into how the API is structured. So the way you can read this is kind of like saying, let's list all the models in OpenAI, reading from kind of back to front. Not all SDKs, or software development kits, or APIs work like this. It sort of makes intuitive sense once we get to know the API a little better. Now we're going to unpack all the elements of this list and just print them to the console so we can see the models. And to do that, we're going to use what's called a for loop. So we'll type for and define another variable called model and say of list. And so that's a notation that when combined with the for keyword, this will loop over the entire list, go from each and every entry in that list and assign it to this variable called model. And here we'll use a globally available object called console and call the .log method on it. And you can see the IDE is sort of giving us some hints and clues as we're typing here onto what these methods do. We'll just put the variable model inside the parentheses. So this console object is available both in node.js in the environment we're using here and in browsers. Makes it really convenient to print out messages to ourselves. And then finally, we're just going to call this main function to ensure that we're running the code. Save the file. It's very important, as the terminal won't actually know your changes unless you save the file. We'll go back to the terminal and type node, and then a space, and then the name of the file we want to run, which is models.js. And there we are. It prints out a whole list of these curiously annotated entries for each and every model that's available. So things like GPT 3.5 Turbo, which might be familiar to you. If we go to the OpenAI website again, here, on the left-hand side in the sidebar, there's an entry that says models. So if you click on that and scroll down, you'll start to see the same list of all the models that are available to us. So things like GPT-4, GPT-4-0613 that has a kind of version number attached to it, and so on and so forth. This table is quite useful because it provides a description of what each model is intended for and what its capabilities are. Things like JSON mode, parallel function calling, and so forth. So there are two models here that have function calling that'll be relevant for us, and we'll show you how to specify those. Great. Now that we have a working API call, let's just take a look again at our diagram. In order to build up our path to function calling, we need to be able to initiate a basic chat completion. So we provide the API with a context and then a user prompt, and then we'll get to a place where it returns a completion for us. And that's the foundation for function calling. Let's go back to our code editor, and then let's create a new file and call it chat.js. And one thing that I like to do, and that we'll do for this tutorial, is build off of the code that we've already written. So I'm just going to go back to models.js and copy this code, and then paste it into the chat.js file. And then I'm just going to erase what's inside the main function for now. And then let's start building up what we need to create a chat with OpenAI. So to review once more, the way that these chats work is providing a context and a user prompt. The model runs inference on that context and prompt, and then returns a completion. We alternate between prompt and completion, prompt and completion. ChatGPT does this behind the scenes. As you're chatting with it, it records each and every message sent by the user and every message that it returns. Every time you add a prompt, you're including all of the context that's built up to that point. When we use the API, we have to do that manually ourselves. The way that we're going to do that is just creating a variable called messages and have that be an array or a list like this with square brackets. Every message is a JavaScript object, so that's curly braces, and it has a consistent structure. And the first key value pair that we give this object is a role. And the role is a cue to the model as to how to treat this given message. The first one that we're going to use is system. And this sets up that context, or again, what ChatGPT calls custom instructions. Every message has a content attached to it. And for the content here, we're just going to say a simple, "You are a helpful assistant." In the future, you'll be able to be more specific with the set a tone of voice, even sort of get specific as to the functions that functionality that you want the chat to take. But for now, just you are a helpful assistant gets us started. And then the next message is going to be our prompt. The role that we need for a basic prompt is user. For us now, this, when it says user, it's a proxy for a human, although it doesn't really have to be a human that generates the prompt. It just tells the model that this is something that's coming that is the basis for the completion that it should run. And then again, every message has a content. And then we'll give it just a simple question or query. Perhaps, what can you tell me about artificial intelligence? And that's it. That's our first prompt to the OpenAI chat completion. Now we have to create the chat completion object, quite similarly to how we instantiated a kind of list query for the list of models. We're just going to create a variable to hold the response, which is completion, and then we'll call the completions API. So this creates a chat completion object for us. So this is analogous to creating a new chat in ChatGPT. Just a bit of notation about JavaScript. If you're new to this notation, this await keyword just cues JavaScript into saying wait for the response, pause and wait for the response from the API instead of charging ahead as JavaScript typically does. And now we're going to give the object the API request two things. One is a list of the messages. So that looks like this with a key messages and then the actual variable that we created above on line 6. And then we'll give it a key value pair to specify the model that we want. Really right now, the fastest model, cheapest model that we can run is GPT 3.5 Turbo. So we'll just specify that. And so this string that we're putting in for the model comes from what we saw before in our terminal when we listed all the models. So this ID key value pair, the string that comes after the ID, these are what are acceptable to input into that chat, into the chat completion object. And now again, we'll just use console.log to print what the completion is. And we'll see what happens. Okay, save the file, go back to the terminal. And so I'll scroll back down to where our prompt is. And I'll say node space chat.js, enter. We wait for a moment, and then we get something, which is great. We get this object. If we inspect it a little bit more closely, it actually doesn't, as it's printed here, doesn't really give us much that's useful. But we can see that there's this unique identifier for the chat completion itself. It gives us a little bit of clues as to what this object is. It gives us a timestamp, which model was used, GPT 3.5 Turbo 0125. If we look into this choices array, we see right here this message object. When Node.js prints out objects to the console, it doesn't go infinitely deep into the objects that it's given. It kind of cuts off at a certain depth and kind of make things a little bit easier to read in the terminal. What we really have to do is access our way through this object so that we can get to this message object to see something more interesting. If we go back to the code editor, one more note, this choices key that we get in the top level object, sometimes the GPT models will return more than one completion, and we get to pick between them. So you'll see this in ChatGPT sometimes when it gives you the option so that you can pick what you think is the better response. Usually there's only one, and so it's relatively straightforward to assume that there's only one choice and we can look at that particular choice. But just keep in mind that the choices array might have more than one element in it. So if we go back to our code here, we're just going to access our way into the completion object. So we'll dot access into choices, and then we'll pick the first choice out of that array, which is sub-0 or square brackets with a 0. And then we'll say dot message, since that's really the piece of information we want to take a look at. So we'll save again, go back to the terminal, and type node chat.js. And there we have it. So now we actually see the actual message and the actual completion. Again, it has this familiar structure that we wrote, so role and content, and it gives us a completion, something that we would expect to see in ChatGPT. So artificial intelligence refers to the ability of machines or computer systems to perform tasks that typically require a human, and so forth. And one thing to note here is the role is set to assistant, which means that this was a completion that came from the API, that came from the model itself. So we're going to be using this and keeping this in mind later. But that's it. So you've actually successfully created this workflow where we have a context and a user prompt and gotten a completion back. And just with this, you could actually create your own little ChatGPT experience here. We could continue writing the code in a way that created an interactive prompt and also would remember each message, and you could have a back and forth. What we're truly interested in is this case. If we were to say something in our prompt that required the model to take into account some external piece of data, so like the current weather in a given location. So this is what we're going to do. We're going to try to cue GPT into knowing that there's a function call available for getting the current weather. And if a user were to ask about the weather, you should tell me that that's the case. We're just going to do this for now. Let's go back to our code editor and see how that actually works. So here again, we're going to create a new file, and we'll just call it function call, function-call.js. Again, we're going to go to our previous file, chat.js, and copy the contents, paste it into our new file. The piece of the chat completions API that refers to these types of function calls is called tools. There's only one tool available at the moment, which is function calling, but we can infer that the OpenAI team are building out different types of tools that we can use. We'll say const tools to define our tool variable. The syntax is a bit verbose. It's all meaningful, but we'll go one step at a time in building this out. Every tool is described as an object similar to a message, so that's curly braces. And the first key that we want to provide is the type of tool that we're creating. So that's type function. Because it's type function, the API specifies that the next key value pair that we give is just called function. And then we provide an object to describe the function itself. The name of our function is going to be get current weather. This is kind of the canonical example that they give in their tutorials about function calls and accessing external data. And then the next key value pair, which is quite important, is the description. Normally, when we look at code in any other context, like say a GitHub repository or a comment around a function in source code, descriptions are typically just text cues to the humans that are reading through that code or browsing through GitHub. Here, however, the description field has actual semantic value. This is the textual cue that tells GPT under what conditions it should tell us that we should be calling this function. So we have to give it something quite meaningful here. So like returns the current weather in a given location. A lot of the design around functions, as you're starting to add these and get deeper into this functionality, is tuning the description so that it is understanding what the user is asking for, so it appropriately calls the function when it's needed. Like any other function in any programming language, they act on a set of parameters or arguments. To specify those, we're just going to say parameters. The parameters that we're going to accept is of type object. And the properties of that object are this. When we're specifying this object, what we're really doing is telling GPT, not only do we want you to say when we need to call getCurrentWeather, we also need some information so that we can make that function call meaningful. In particular, that's the location that we want the weather of. It doesn't really make sense to say getCurrentWeather in general, but if we have a specific location, now it's meaningful and we can go to a weather API and get that weather. For the location here, we're just going to say type string. We're also going to provide a description. Just like the description for the function, this has semantic value. So we should provide something meaningful so that the LLM knows what we mean by this. Here we're just going to say city and country. And then, for example, we'll just say like San Francisco, California, USA. This is pretty much all that we need, although we're going to add one more cue to the LLM, which is to tell it which of these parameters are required. Right here on the same level as type and properties, we're going to add one more key value pair that's required. And what this does is it tells GPT which of these properties it must return for us to give a meaningful function call. And so in that case, we only have one, which is location. All right. And then a couple more things. Lastly, we actually have to pass the tools into our completions call. So the way that we do that is providing another key value pair down here after model, which is tools. And then we're going to be a little bit more specific about which model to pick. Right now, GPT 3.5-Turbo is aliased to this version -0125. We do this because 3.5 Turbo-0125 is one of the models that has function calling as one of its features. Then save the file and go back to our terminal and type node function call.js, and let's see what happens. Oh, you know what? It's giving us the same exact answer because I didn't change the prompt. I'm not actually asking about the weather. But if we go back to our code here, go back to the original prompt, what can you tell me about artificial intelligence? We have to change this to something that is location and weather related, like what is the weather in New York City? So now you can see the actual difference. If we run the same code again, now we get a different response. This is quite typical of a function call response. Let's look at the object that we got. So first, we have the same role, which says assistant. This gives us the provenance of this message. So it comes from the AI itself. It has a content key value pair, but the value is null, meaning that there's no actual textual response. And instead, we have this new key value pair, tool calls. We're getting a list of something that's telling us that we need to call upon a tool. The tool that we need is a function of some type. And then you'll notice that the value, again, is this generic object. And so we're running into the same phenomenon here where Node.js is not showing us the kind of infinitely deep structure of the object. So we have to access our way to function to see what we have. So let's go ahead and do that so we can figure out what's inside this object. Let's go back to our code editor, scroll down to where we have our console.log function. And so what I'm going to do is, since this message is meaningful, and actually remember, since we have to remember all the messages that we're having with this chat, it'll be quite useful for us to just store this in a variable so that we can use it later. So I'm going to cut it out of the function call and assign it to a variable called message. And then we have to access our way down to the actual function call. So let me look back at the terminal so that I know what to look for. So the first level is this tool calls key. So we can dot access our way to that. It's an array, so we can index our way to get to this first object here. So we'll say message.toolCalls. And then we can access the first one the same way we access the first choice, like this. All right, let's see what we get. So I'm going to run the completion again. Aha! This is the first tool call or function call that we have. And now Node.js is showing us what's inside this function key. And it says the name of the function we're supposed to call is getCurrentWeather. And now the arguments are this string that has an object notation inside of it, where the location is New York City, New York, USA. So that's great. This is exactly what we wanted. It's not doing much yet, but it is showing us that our description for the function is working, and it's returning a structured response that has the information that we actually need, which is to compute the weather for a particular location. That's great. So this is our first successful pass at our full function call lifecycle. We are able to cue GPT into saying, like, watch out for weather questions. And then when you see a weather question, tell me that I should go and call my weather function. Now we're going to continue on our journey and create a kind of fake weather call here, where we call out to a weather service and then return a result that then we need to bundle and send to OpenAI again. We're not actually going to access a weather service directly yet. We're just going to create a kind of fake weather service and return a hard-coded response that gives some idea of the weather in any given location, just so that we can engage with what it's like to create this structured response and then bundle it up. So let's go do that. Let's create a new file, and in this case, we'll call it fakeweather.js. Again, go back to our previous file, copy its contents, and paste them here. And we're just going to pick up where we left off. And where that is we need to do the work of getting to a place where we can actually call a real function called getCurrentWeather. Because all that we have right now is a response that says, the user's asking about weather. I know you told me before that getCurrentWeather is the thing to call, and here I've given you the location that you told me was required in order to fulfill the user's request. Let's go ahead and do that. And then, again, this point that I made before about we have to remember all the messages and kind of bundle them together. Graphically, in our diagram, that looks like this. We have to bundle up all of our interactions and send them to OpenAI every time we make a new request to the Chat Completions API, so that OpenAI has all of the context that it needs to make a meaningful response. Here, I'm going to reference our messages variable again from above and just add on the last message we got from OpenAI. Now our challenge is this tool calls array that has an object that describes a function call. Now we have to go through and do the work of identifying and calling all the functions that OpenAI has requested so that it can have all the information it needs to complete the conversation. In a more complete version of this code, I would check to see the existence of the tool calls key. Just for illustration purposes, we're going to assume that the tool calls array is there. And we're going to loop through every tool call like this. So similar to our first example where we had an array of objects that describe the models that are available in the API, we're going to use the same for loop and then loop through every tool call in that array called tool calls. If we look at the structure of that object once again, we can see that it has an ID, that's a unique identifier for that particular call. This is a way for GPT and OpenAI to keep track of all the information it needs for that completion. It has a type function, and then it actually gives us the details about the function again, so .name and .arguments. For us to do this properly, we're just going to access into the name and arguments so that we can check for the function call itself. Let's go back here, and we're just going to pull out the function name and the function arguments like this. Function name equals tool call dot function dot name, and const function args equals tool call dot function dot arguments. So this mirrors the structure of that object directly. There's one peculiar part about the arguments that we have to take a look at here. So if we go back to the terminal once more, you'll see that the value of the arguments key is actually a string. And inside that string is a JSON object notation. In order for us to actually get the location in a meaningful way, we can't use the string directly. What we have to do is parse it so that we can convert this string into a usable JavaScript object. To do that, we're going to go back here, and node.js provides us with this global JSON object, and we'll say just .parse, and then wrap our object accessing in parentheses. So this will do the heavy work of parsing the JavaScript object notation string into an object, as it has here in the help text. So now we're ready. Presumably, in the future, we're going to have many different functions that we can call upon. So if we're creating, say, a conversation about cities, we might ask for the weather in that city. We might have other functions that give us demographic data, like its population, and so on and so forth. So what we're going to do is set us up for that kind of pattern, even though we only have one function, and say if function name equals get current weather. And in the future, we'll be able to test for all sorts of function names like get city demographics. And here we're actually going to call the function. This is the meat of it here. We're going to say function result equals, and then get current weather. And we're going to pass in the parsed arguments that we pulled out of the tool call object. So great. The curious part about this is that we haven't actually defined the function yet. We've just called it, assuming that it exists. But let's break out of this snippet of code here and actually write the function itself so you can see what we're trying to achieve. So I'm going to pop down here outside of the main function to line 54, and I'm going to create another function called getCurrentWeather. And I'll just have it accept one parameter, which is this generic args variable. If you're new to Visual Studio Code, I was able to autocomplete this by just pressing tab after typing just a few letters. Here, we're just going to return a fake stub response. So I'm going to return an object that like weather response with a weather response key, and I'll give that a string like it's 38 degrees Fahrenheit and cloudy, we'll say. And this starts to show some of the neat parts about interacting with a large language model, particularly with function calling. We can give it not only structured responses like this, but also pieces of that structured response can be unstructured, like a sentence like this. It will know, based on the context and the descriptions and the prompts that we've given it, how to interpret this sentence, which is pretty awesome. Let's go back up to line 49 here. We'll add a new message that represents the response from the getCurrentWeather function call. Here we'll just add an object. This has a very peculiar structure as well. It's defined in the API, and it takes 4 key value pairs. So the first is going to be tool call ID. So if you remember, in the structure of the response object that we got for the function call, it has this unique identifier here. So we have to reference that so that as GPT is going through the list of messages, it knows that we successfully called get current weather and that this request for a function call has been satisfied. We can't really copy paste this value in because we don't know exactly what it's going to be. You can see the previous function call up here has a different identifier. So we just have to dot access into the original tool call object to satisfy that requirement. So we say tool call dot ID. The next one will have a role. So far, we've seen 3 roles. We've seen system, user, and assistant. This is the 4th type that we're going to work with in this tutorial, which is tool. The 3rd key value pair is the name of the function, and we've already pulled that out. So we can just say function name, the value that we have up above on line 43. And then finally, the message has a content. The content should always be a string, just like we received a content before from the tool call that we had to parse into a JavaScript object to make that meaningful for us in interacting with it as code. We have to take the response from the get current weather function and turn that into a string. So this same JSON library has a method called stringify. And then we put the function result as the sole argument into that stringify function. Great, that is the structured response that we have to give it. Now we have to interact with the OpenAI API again. So we've done this bundling step here where we've combined everything together. Now we have to do this last piece here where we send that bundle of messages back to OpenAI. To do that, we're going to create another chat completion instance. So we'll store the result of that. We'll just say something general like completion 2. And then again, we'll await for the response. OpenAI.chat.completions.create. And we'll use the same structure as before, messages, which now contain the original tool call request and our response. And then we'll specify the model again. And that's it. And then finally, we'll dot access into the message that we get from this completion, the same as we did before. So console.log, and in this case, completion2 dot choices sub 0 dot message. So we're going to assume it's the same structure and that all is well with our request. So save the file and let's see what happens. So we're going to say node fake weather.js and wait for a bit. Uh-oh. Here I put message.push instead of messages. I referenced the wrong variable. So I'll go back and fix that right here on line 49 and run again. Aha! Remember, we have multiple console.log statements. So we have this, which is the tool call itself, but then we have the final response from the API, which is an assistant response that says the current weather in New York City is 38 degrees Fahrenheit and cloudy. That's great. That's exactly what we wanted. It's a little bit of a letdown because the response that we're getting is stuff that we already coded ourselves with the fact that it's New York City and 38 degrees and cloudy. But at least it demonstrates the whole flow here. And so not only have we bundled all of our messages together and called a function, we've also gotten the last completion. We've actually done the entire lifecycle of a function call now. We've created the context, the prompt, the tool definition, the function call definition, called into a fake weather service, bundled that all together, talked to OpenAI again, and gotten the final completion. That's great. But wouldn't it also be great if we could access a real weather service and actually make this a meaningful demonstration here? Let's go ahead and do that. There are many, many weather APIs available. Most of them are paid, but we have access to this one, openmedio.com, which is a free weather API. And it's actually a rather simple HTTP endpoint that we can access for weather data. Let's go ahead and do that and see the example that it has here where it gets quite a bit of information from this. We can look at some of the parameters of the request format here. We can give it a latitude and longitude, and then some cues into what information we're interested in, like the current temperature, the wind speed, and so on and so forth. We can run this test in our terminal just to see what we get first. So I'm just going to copy paste that example into the terminal and then run it. And you see we get kind of a lot of information here from the API itself. This just demonstrates that we can successfully access that API. To use this in our code, what I'm going to do is, again, create a new file, which I'm going to call weather.js. So this will be our kind of real weather API access. And then again, copy the code from fake weather into weather. Let's take a look again at this API. So I'm going to copy this for reference into our code. And where I'm going to do this is inside our getCurrentWeather function, just so that we have something to look at. Let's do this rather simply. To specify a location, we have to give it a latitude and longitude. And then let's say for the moment, we're only interested in current temperature. So I'm just going to pull that out and then create another comment here for that URL. What we'll do is we'll construct this URL and make the request, instead of from curl on the command line, we'll make the request here in JavaScript. Just to test this URL, however, I'm going to go back to the terminal and use the same curl command and give it this URL and see what it returns. Here, the response is much simpler. We have a kind of queue into the units that the temperature part of the API is returning, so degrees Celsius. And then we have what looks like the temperature in degrees Celsius here. This is the kind of response that we're looking for. That's great. I'm just going to do that in JavaScript. So how do we do this? Well, first, there's a curious piece of this, which is the fact that the API takes latitude and longitude instead of a place name like New York City. What we're going to do is to find the latitude and longitude, we're just going to ask GPT for it. We're just going to say, hey, when the user specifies a place name, also compute the latitude and longitude for that place name for us. We could access another database or another API that has place names and latitude and longitude, but GPT is rather knowledgeable about such things, and so we should just take advantage of that fact. So the way we can do that is if we scroll back up here to our tools definition, which again is pretty verbose, but in the properties of our tool call, we can tell GPT not only do we want the location as a place name, we also want the latitude and longitude of that. So I'm just going to add here latitude as another property that we want. We'll say type, instead of string, we'll say type number. And then we'll give it a description. Again, something semantically meaningful. So we'll just say the latitude of the city the user is asking about. And then we'll do the same for longitude. Type number. And then the description. The longitude of the city the user is asking about. And because the API requires a latitude and longitude, we also want to tell GPT that latitude and longitude are required so that we don't get a tool response that does not have those data. Great. Let's thread this information through our code because eventually we want it to get down to the actual function call for getCurrentWeather. All of this code that we've written so far should accommodate that. And so it will parse those arguments that it gets back from the function call. As we come down here, those arguments are going to come through when we call the getCurrentWeather function. Now we have to create a way of inserting the latitude and longitude into a URL so we can make this function call. What I'm going to do is create a new variable called URL. I'm going to create a string, but I'm going to use backticks here. So those of you new to JavaScript, when you use backticks, that gives you the ability to interpolate values into a string. I'm going to copy this URL again. It also has other niceties and like multiple lines and whatnot. But what I'm going to do is where it says 52.52 for the latitude, I'm going to interpolate using this $ open and close brace notation and say args.latitude. So the function arguments that we get should have 3 properties attached to it. It should have a location, which is a textual place name, a latitude and a longitude, which are numbers. So we can just dot access into them like this. And then finally, we'll do the same thing for longitude. Great. And so now, instead of returning this fake weather response, we're going to actually call the OpenAI API. Node.js and browser environments give us this method called fetch that allows us to do HTTP requests on our manually. So we can say const, we need a variable to record the response of that fetch request. We'll say fetch URL. This URL request will take time. We don't know how much time it will take, but we can't really charge ahead and let it finish on its own. We need to be able to combine all the values that we get from every function call together in order to make a meaningful message to send back to OpenAI. So we have to await the response. And in order to use the await keyword, we need to define our function as, we need to decorate our function with the async modifier. Now, when we get the response, we're going to send that raw response back to the caller of this function. And we would like this function to send back a kind of structured response. So if you reference the terminal again, you see that the response is this JSON notation. We can use a feature of that response object to return a JSON response. So we can say response.json and return it as the value of this function. And in line with that, now that this function is something that requires waiting for the response, we can go back up here to the actual function call on line 55 and also say await. That should be it. We haven't really done any testing incrementally. We just kind of implemented all that at once, but let's see what happens. So we'll go back to our terminal and type node weather.js, and we'll see what happens. Great. We see the definition of the function call here, which again is getCurrentWeather, and we can see that our prompting for multiple required properties has worked. We have the latitude and longitude coming in as well. And then we get the final response, which is the current temperature in New York City is 12.9 degrees. Now what we can do is, we can first verify if that's the case. Let's see what happens. It looks like at least in the macOS weather app, it's also returning 12 degrees Celsius. To test this, again, let's give it a different city and see what happens. So instead of New York City, let's give it, say, Lisbon, Portugal. I'll go back to the terminal and run our code. And there we are. Now it has Lisbon, Portugal, and then it says the temperature is 11.6 degrees Celsius, and then we can verify that here. Again, rounding up to 12 degrees. So great. So now we actually have a working mechanism that calls a get weather function based off of a user's textual prompt. It actually calls a real weather API. Then it uses GPT as well to take the place name that the user is talking about and compute the latitude and longitude so that we can access this particular API. That's the entire life cycle of a simple function call. And again, in the near future, we can look at how to expand this. If you imagine like a chatting with places workflow, we could add more and more functions to get information about those places, say from demographic data sources, even more place names, and so on and so forth. So I hope you found this useful. This will be the first of several tutorials like this. Thanks very much for listening, and I'll see you next time.